So here's our next optimization algorithm, and that's union by rank, but this time by height. So this one is really using the height out of the tree, but we have to be careful on when we're doing any type of merging or union of a tree. That's how we're going to keep track of all of the heights that we've been doing. So it's a slow build into that. Now here's the other interesting part. The height value is always negative. And I'll show you that here in an example, so bear with me in a moment. If it's not negative, then we know we need to move to that particular node. So what did we have before? So first we had the union by rank, and again, this was the size of nodes, and here's the data set. And notice that index 4 has -5, and the 5 is just all of the values that we have here in this circled area for the 5 nodes. Now, that's what we had before. Now what we're going to have is a union by rank, and this time height. So notice it's the exact same tree. There's nothing crazy about it except for, if you can believe it, this time it says -3, and that's because there's 3 levels to this tree. Now, we have to be careful because every time that there's a root, notice -1 for 0, that's how many heights there are in that node, and we would have to worry about it each time we add a new, well, if we merge or union 2 nodes, it would increase its height to 2, be a -2, whatever the root is. So every time these values get unionized with somebody else, they're going to at least increment by 1, whoever the root is, each time, so we can keep track of the overall height. So we don't really need any extra variables or anything else like that, but it's just a different mindset this time on exactly what we're tracking. Instead of size, we are tracking the union by height. So that's the difference between what we have from union by size and then using union by rank when it comes to height. What if both trees are the same height? Order does matter when it comes to this. So I've had this question pop up a couple of times. So in this, what we're going to do is that we have 2 trees that are exactly the same height, as you can see drawn here. And if we union 6 to 12, now remember, this is the child and this is the root. This would be the correct answer for that because of the order, 6 and 12. 6 is the child, linked to the 12 because of how this is literally written out here. So we have to be careful because if it was union 12 and 6, because they're exactly the same height, yeah, 12 is going to then link to 6. So we have to be careful about order when it comes to calling our union. Now don't forget, every time we've done a union so far, we had to do a find on each of the sets to make sure that they already weren't together in a set. So don't forget about that part as well. So that's what we have for our by height instead of by size.